Okay, this is the Fika Academy. Today we want to look at a very key theorem called factor theorem. I have decided to look at it because it's applicable across every part of mathematics. Say numerical analysis, say linear algebra, say in ordinary differential equation, say in a partial differential equation, we normally use factor theorem. So what is factor theorem? What is factor theorem? If we have a given equation PC here, and you find that if you substitute that given C in that equation, you get 0. Okay, then you'll find that this x minus C, because a function, of course this function is for a function of a given of x, you'll find that it will divide px. So you're having a given equation px, and you find that you have some given constant or solution that is giving u 0. Then that particular x minus c, then it will be able to divide px. Again, if you find that particular pc gives you a constant d or a solution d, then you will find that if you divide x minus c with px, then the remainder will be that particular d. The remainder will be that particular d. Let us demonstrate this so that you see it clearly what I mean. So if this is our px, but in this case we have a function of k, and this is the equation that we have here. So if a solution that will give this one to give 0, with p1. So if you substitute 1 here, cubed minus 7, 1 squared, okay, 1 squared plus 40 minus 8, the answer will be 0. So what do you want to demonstrate? I want to demonstrate whether this x minus c, which is 1, divides the px. In our case is pk. So we need to have pk here and k minus 1. If this divides this, we are saying, if we divide this one from our equation here, our theory here, there will be no remainder. The remainder will be 0. The remainder will be 0 in our case here. So that's the reason we are saying our remainder, if you expand this one, the pk will be written like, it will break into a quadratic equation times our x minus c plus a given d. But we obviously know that the remainder will be 0. So that's the reason obvious d will be 0 there. By now you can hear, if you want to solve for values of a and b, c, you normally equate the coefficients. So you do one if k is equal to 0. What will happen here? That becomes 0, 0, 0, 0, 0, negative 8, 0, 0. So you have c left, and so you have cx minus 1. If you expand, you'll find that a is 1, b is negative 6, and c is 8, and d is 0. So that now, in this case here, you'll find that we have a quadratic expression which is basically this, that. And by using the laws of factorization method in a quadratic formula, you find this will be broken to that. And by using factor theorem, we can see clearly we have simplified our pk, which was a k cubed, to this particular product of factors. So that if you are trying to solve this, you just equate this to 0 and you find that our solution to k is 1, 2, and 4, which are actually the roots of the equation. They are the roots of the equation. So note that if you find that particular constant gives you 0 if substituted into the equation, then there is no remainder. The remainder is 0. But if it gives you a given constant d, or solution number d, then you know that that particular d is the remainder in that of that polynomial if divided by that given factor. If you have question on this, you can leave a comment. If you have clarification, leave a comment. So that is it on factor theorem. I have used factor theorem in various tutorials up there about ODE. So in ordinary differential equations, we normally apply these ones because we need to solve for roots. When we are solving homogeneous differential equations, we come up with the roots. Distinct roots, repeated roots, after getting the characteristics equation of an ODE, and therefore I find it important to look at it. So kindly share and subscribe if you have not yet subscribed. Until next time, bye.